Okay, so to find the volume of something like this, remember that volume is equal to the area of a base times the distance. You know, if it's a box, of course, the area of the base is just length times width, and then the distance is the height. So length times width times height is our standard formula for a box. This, of course, is not a box, so we first have to figure out what the base is. Remember, we said the base is that shape that goes throughout the object. And in this case, that is this shape here. No matter where I slice that object, that's what shape the end is going to be. So we got to find its area. We could build it up to be a bigger rectangle and subtract out pieces. Or we can chop it into smaller rectangles and add them together. This one's about the same amount of work either way, so I'm going to chop it into smaller ones. So we have 1, 2, 3 pieces we have to find areas of. So for the area of the base, area 1, that rectangle is how big? 120, good. It's 12 inches by 10 inches. That's 120 square inches, or inches squared. Object 2. It's 8 inches here by how much the other way? Yeah, 12 plus 4 makes 16 inches. So that's 128 inches squared. Object 3. What's this length here? Yeah, if it was 16 all the way up, we subtract 10, that has to be 6. What's this distance here? 6 as well. This is 10 and 8, so it's 18 from here to here. 24 minus 18 leaves us with 6. So 6 inches by 6 inches is 36 inches squared. So we add that up, we've got 284, I believe, inches squared. Does that look right for your area of base? So now that we have that area, the volume is just that area times the distance to the other side, which is 12. So 284 times 12 is 3408. And inches squared times inches is inches cubed, or cubic inches. How many of you got 3408? Good deal. Anybody have questions on how we got that? Anybody have questions off the homework from yesterday? It's page 17 to 19, 1 through 39, the odds. Okay. Please feel free to take as much time as you need to finish up the quiz. We're going to go ahead and start our new material here quick. So if you'd set the quiz aside for a minute and take notes, we'll have time to finish it up at the end of class here in the homework time. So we've been talking about these areas, and what we've been using some formulas without really addressing it. You know, we had the formula area is equal to a length times a width. Or we sometimes put it as a length times a distance. And what we did for that is when we had a rectangle, if we had a certain length and a certain width, we put those numbers in. 14 went in for the length, 5 went in for the width. So it just becomes area equals 14 inches times 5 inches. So we got the 70 inches squared. And we did the same thing for volume. Well, today we're going to look at that same concept. We have a formula that we're going to plug numbers into. It just might look a little bit more complicated. For example, the area of a triangle. The area of a triangle is the length of the base times the height divided by 2. So for a triangle, the base is the bottom here. Let's say that base is 15 inches. The height isn't necessarily one of the sides of the triangle. In this case it is. The height is perpendicular at a right angle to the base. So the height here, let's call that one 6 inches. So the area of this triangle is that base of 15 inches times the height of 6 inches divided by 2. 15 times 6 is 90. Inches times inches is inches squared. Divided by 2. 90 divided by 2 is 45, and there is nothing divided in the inches squared, so it stays inches squared. So we just plug the numbers into the formula to get the result. Go ahead. Sometimes the formula is written as 1/2 base times height, but since we haven't done fractions yet, I didn't want to put a fraction in there. Sometimes they tell you to cut it in half.
If you were to take, well, I don't even want to say it because then people try to do it and they'll be mad at me for not doing it, but you can take 2 divided by one of the top numbers.
Yeah, that's one of the shortcuts. Cut the 6
okay.
in half and make it a 3 and then multiply it. Yeah, that's one of the shortcuts if you're looking at calculating it really quickly.
I don't want to say anything.
Okay, no, that's fine. It does work. If you're calculating in your head, that's a very quick way to calculate it. Divide one of them by 2 first, so you're multiplying smaller numbers. The theory behind that, of course, is that a rectangle is just base times height, or length times width, or whatever. And a triangle is just half of that rectangle, so you divide it by 2. We want to look at the area of a trapezoid. A trapezoid looks like this. It has 2 sides that are parallel. So these 2 sides are parallel and the other sides are not. Well, the only thing that we know how to find the area of is a rectangle. We gave this formula here for a triangle, but that's based on a rectangle too. It's just the area of the rectangle divided by 2. The trapezoid we're also going to turn into a rectangle. Here we have 2 bases. Call it base A and base B. Sometimes called base big B and base little b. And then there's a height. Or a distance between those bases. If we're looking at this, trying to make it into a rectangle, what we can do is we can go halfway down the side here and cut this off square. If we flip that piece up, it fills it in. We've squared off that end of it. We can do the same over here. Cut this off square, flip that piece up and fill it in. Now we have a rectangle. The height of that rectangle, or the width of the rectangle, is still the height. It's the length of the rectangle that's in question. The length of that is between the length of base A and base B. What it comes out to be is exactly in the middle, the average of the 2. So the length of that rectangle is A plus B divided by 2. Add together base A plus base B and divide it by 2. Gives you the average of them. So that gives you the length of the rectangle. To complete the area, you multiply by the width or the height. So the area of a trapezoid is A plus B divided by 2, and then times the height. So if I give you a trapezoid, it looks like this. Let's say this is 16 inches, 24 inches. I call that 10 inches. I have to plug the numbers into the formula. What goes in for A? 16 will work. Then for B, 24. Does it matter which one I make, A or B, the 16 or the 24? No, those 2 have to go in for A or B, no matter what order it is. And divided by 2, and then for H we put in 10. So now that we've put our numbers into our formula, it's just a matter of order of operations. We have to do enclosing symbols first, our parentheses. We do the top of that. 16 plus 24 is 40. There's nothing to do on bottom. So now we're going to divide. 40 divided by 2 is 20. Parentheses are reduced to a single number, so I can take them out. 20 times 10 is 200. The units there are going to be inches squared, or square inches. This would have been 16 inches plus 24 inches is 40 inches. Divided by 2 makes that 20 inches. And that is 10 inches. So inches times inches is inches squared. So in your notes, find the area. Of this trapezoid. Now, even though it's slanted off to the side, the 8 and the 26 are still the bases, the 12 is still that height. So go ahead and plug that into the formula and find the area. So A and B are going to be 8 and 26. Doesn't matter which order we put them in. H is 12. First step is 8 plus 26 is 34. And then 34 divided by 2 is 17. Don't need the parentheses anymore. We're down to a single number. 17 times 12, 204 inches squared. Good. How many of you had 204 inches squared? How many of you just needed a minute to get to it? All right. Anybody not understand how to do it? Yeah, I know. Always going to be 1 or 2 people to get cut off, unfortunately. Okay. Well, there are all sorts of other formulas out there that we can deal with. One is our formula for work. The scientific definition of work is a force over a distance. So a force times a distance. The more force you exert, the more work you're doing. The further you push it, exerting that force, the more work you're doing. So the formula ends up being W equals F times D. So if you are pushing or exerting a force of 100 pounds over a distance of 20 feet, the amount of work you do is 100 pounds times 20 feet. 100 times 20 is 2,000. Pounds times feet is foot-pounds. So foot-pounds is a unit of torque that we saw before. It's also a unit of work. You see something called horsepower is what you're used to seeing. Power is the next step in work. Power, talking about mechanical power, is work divided by time. So it's not only how much work you do, but how fast you do it. Power is the ability to do work at a given rate. So I could do work divided by time, or I could do force times distance divided by time. Either one of those formulas works for power. So let's say that this one up here, that 2,000 foot-pounds, that 100 pounds over 20 feet, we could do that in a time of 5 seconds. So the power produced there is our work of 2,000 foot-pounds divided by 5 seconds. So we do 2,000 divided by 5 is 400, and the unit there is foot-pounds per second. Now, there are other units that come in there, like joules and stuff like that, but we're not going to get into the other units for now.
What's the theorem? Power equals what work?
Divided by time. 1 horsepower, I believe, is 11,000 foot-pounds per second. you're looking at electrical horsepower, I think it's like 743 watts per second. Okay. Let's say that I'm giving you, that you move 80 pounds over 120 feet in 15 seconds. Find the power in your notes. Find the power produced. We're using this formula here. I'll give you a little bit more time. Okay, so we put this in our formula. Our formula, power equals force times time, or force times distance over time. What goes in for F? 80 pounds. What goes in for D? 120 feet. And for T? 15 seconds. So we have to multiply on top first. 80 times 120 is 9,600. And pounds times feet is going to be foot pounds. You put them as pound feet, but it makes more sense as foot pounds. Over the 15 seconds now, we divide by 15. What do we get? What's that?
Well, 640.
640. There you go. And so that is foot pounds per second. Any questions? How many of you had that? 640. If you didn't have the units, I'm not worried about that for now. Well, one of our more common formulas we have, speed or velocity is equal to distance divided by time. If you travel 450 miles in 9 hours, what is your average velocity? Well, it's just 450 divided by 9 is 50 miles per hour. Notice when we divide the units, the unit we're dividing by ends up on the bottom of a fraction. Those of you in automotive, you're going to see a lot of electricity before the year's over. In dairy, you'll see a little bit of electricity in the spring when you guys talk a little bit about some of your equipment and stuff. Basic electricity is important for a lot of the things you're going to do on the farm. Two of our basic formulas, voltage is equal to current times resistance. So that's voltage, current, and resistance. So if I have a 12-volt battery pushing through the 12-volt batteries here. If I have 12 amps of current pushing through 2 ohms, the symbol for ohms is this upside down horseshoe that we saw in some of the homework. So 2 amps pushing through 2 ohms. 12 times 2 is 24, and an amp times ohm is a volt. Again, I don't expect you to know how to handle the units for now, but just be able to do the numbers. 12 times 2 is 24, so your voltage is 24 volts. 12 amps, by the way, is a lot of current. 1 or 2 amps is usually the highest you're going to get. Most of what you're dealing with in automotive and stuff like that, you're dealing with milliamps, or a couple hundred milliamps, like 0.2 amps. So anyway, that formula can be rearranged for different purposes, however. Many times it's not the voltage that we want to find. We know the voltage. So we might rearrange it like this to say that the current is equal to our voltage divided by our resistance. Because our car is a 12-volt system. So we need to know that if an object has 3 ohms of internal resistance, what current is going to flow? So we'll set that up. Our amount of current is equal to our voltage, 12 volts, divided by our resistance, 3 ohms. 12 divided by 3 is 4. Now again, I don't expect you to know the units. If you just have 4, that's fine. A volt divided by an ohm is an amp. Well, along with that in electricity, another very important formula is power. Power can be done in several ways. Power is current times voltage, or power can be written as current squared times resistance, or power can be written as voltage squared divided by resistance. All of those are going to give you the same result. Let's take a look at that. So if I have 3 amps going through 12 volts, my power will be 3 amps times 12 volts. 3 times 12 is 36. Again, I don't expect you to know how to deal with the units quite yet, but an amp times a volt is a watt. So 36 watts. Well, if I have 3 amps over 12 volts, my resistance has to be 4 ohms. Again, let's back up to this formula here. 3 amps times 4 ohms makes 12 volts. So that resistance would have to be 4 ohms. So I could find my power using my current of 3 squared times my resistance of 4. 3 squared is 9 times 4 gives us 36. We get the same result. Or I could use that my power is my voltage squared, so that'd be 12 squared divided by the resistance of 4. What's 12 squared? 144. Divided by 4 is, again, 36 watts. So oftentimes there are several formulas that will get us to the same result. These formulas here all represent power, but we use different formulas depending on what information we have available to us. Now I had all 3 pieces, the current, the voltage, and the resistance here. But sometimes we'll only have 2 out of the 3, so we pick the formula that has what we need. If I only give you, it's a 12 volt system and we're dealing with 6 ohms. Which formula am I going to use? Will I use A, B, or C? Well, I have voltage and I have resistance. Which formula deals with just voltage and resistance? C. So I'd have to use that formula to find my power. So my power is equal to the voltage of 12 volts squared divided by my resistance of 6. 12 squared is 144. Divided by 6 is 24. So 24 watts. So that's one of the first steps in using these formulas, is looking at what information you have and picking the formula that's going to work for it. Anybody have any questions? And of course, once you pick the formula and put the numbers in, like we've seen here, it's all just our order of operations. In your books, on page 22, 1 through 29, the odds, goes over using formulas, plugging numbers in to get a result. This is probably one of the biggest math skills. I mean, we're going to do some algebra and solving equations, which it's a thought process you guys use a lot, but you don't actually do it out formally. But this process of plugging numbers into a formula is something you will use a lot. For those of you in dairy herds, you might have feed formulas where the amount of feed you give to a cow is based on their production, a certain number of their times of production plus a factor for their weight or whatever. So there's a lot of formulas. For those of you in automotive, your horsepower, your estimated horsepower is your cylinder displacement times your RPMs times also your compression ratio and stuff like that. So there's all sorts of formulas out there we'll work with. So go ahead, page 22, 1 through 29, the odds. Practice those. Same as always, check your answers out of the packet. If the first couple are easy, skip ahead a few. Thanks, sir.